Welcome along to this talk on containers for Pentesters. So I'm guessing by now a lot of people, and we've even seen examples in the previous talk, of people using containers for a variety of things. What I wanted to do with this talk was talk a bit about containers, get that to go where it wants to go, and then talk a bit about how they work, because when we're looking to use things, especially as pen testers, which is kind of the point of this talk, we want to understand how they work, because if you're doing pen testing, you can be doing some funny stuff. It's easier to do that if you understand what your tools are doing and how they actually operate. And then I'll talk about some gotchas and some ideas you can use when you actually want to make use of these things. So, before I get started on the talk, that's not going to work. Let's do this. Very quick about me. Why am I giving this talk? So, my background is pen testing. Until fairly recently, I was a pen tester. I did this for a number of companies for a number of years. Laterally, I was looking at a lot of containerized environments, a lot of Docker, a lot of Kubernetes. These days, I'm a senior security advocate at Datadog. If you've not heard of Datadog, we're a large SaaS observability and security company. A couple of things I do in the kind of cloud native community or Kubernetes container community. I help maintain the CIS benchmarks for Docker and Kubernetes. Has anyone ever used either of those CIS benchmarks or used CIS benchmarks? Okay, if people haven't used CIS benchmarks, they are vendor neutral hardening guides that you can get for pretty much any technology you want. I help maintain the ones for Docker and Kubernetes. I'm also a member of Kubernetes SIG security and the CNCF tag security. These are kind of like special interest groups. So if you're interested in like cloud native security or container security, they're very easy to get involved with. You just come along to a Zoom call, either weekly or bi-weekly, and they're a good place to find out what's going on, to get some new discussions. So if this is an area that you find yourself interested in, very much recommend coming along to those. So the first thing I wanted to talk about was, what is a container? Because this is really important and not necessarily that widely understood. Essentially, when you start a Linux container, what you are doing is starting a process, right? You're starting a program just like you are starting any other program. So containers are just processes. It's an important thing to remember. The way that containers differ from your ordinary processes is all these kind of boxes that go around it. And these are all different ways that essentially the process is isolated from any other process running on that machine, or isolated from the underlying host. That's why if you're in a container, you can't see, by default, all the files from the rest of the host. These are all existing Linux features. These are all things Linux does. You can use these without using containers. And I'm not going to go a lot in depth into those because it's quite a long topic. If that one is one that's of interest, like how exactly do namespaces work, then there's actually a series of blogs that I'm doing at the moment on Datadog Security Labs where we go into a lot of detail about each of those one in turn. And I've got a link to that at the end of the talk. Now, as the last speaker was willing to do live demos, I thought, why not? Let's try and do some live demos. So I'm going to demonstrate this, try and make it a bit more real, a bit more kind of like, yep, that's what's going on. So let's go to, right, I've got a machine here. This is just a Linux host running Docker. And I'm going to do PS. We're going to do PS FC Nginx. So what I'm doing here is I'm saying to this machine, do you have any Nginx web servers running? The answer is, no, I don't. Okay, cool. So then what we'll do is we'll say docker run. Helps if I can type. Not that one, that one. We're going to use docker run, and we're going to run a container based on the Nginx image, which is that bit at the end. We're going to give it a name. We'll call it web server, and we'll write in the background. So at this point, I'm now running a Docker container. That's what I just did. Ran a Docker container. However, from the machine's perspective, from this host's perspective, what have I done? I've started Nginx. As far as that host is concerned, all I did was start the Nginx process running on the machine, just as though I'd installed Nginx and started running it. Because it doesn't know about containers. The underlying host doesn't know what container is. It just knows about processes. So it thinks, you're running a process then. And I'm going to make note of this PID, this process ID. Because one of the cool things, that once you know that containers are just processes, you can interact with them just by using Linux process tools. You don't have to use the container tools. And we can demonstrate that. Let's put this at the top. We'll do docker exec. I'm going to do docker exec. So docker exec just executes a command inside a container. And I'm going to create a new file by saying touch my new file. Give me anything I want. Right? I'm just going to create a file inside the container. Once I've done that, and then say I want to get access to that file. Say I want to mess around with the files on my container, and I don't want to use the standard container tools. Well, because we know that containers are just processes, I can go and find that process's file system and play with it. And in this case, all we need to do is do sudo ls/proc, and then my process ID, root. What I'm doing here is I'm going to list the files in a directory in the proc file system in Linux. Now, the proc file system is a special file system in Linux. It contains information about every process running on the machine, amongst a lot of other things. And one of the things you can do in the proc file system is get access to the root file system of any process. Containers are just processes. I can get access to any containers file system by going through proc. And as we can see, I can. So you can see there, all those files there in the root file system are essentially what comes from the Nginx image, plus my new file, which is the file I just created. So literally, once you know containers are processes, you can just play with them, use them like processes. And if you're a pen tester, you're thinking, well, how can I use these things? Well, hopefully that makes it a bit easier. You think, okay, I understand how this works. So demo 1 worked. Awesome. So what's Docker, right? So I used a Docker command there. The stuff I've been running so far has been Docker commands. There are other container tools available, but Docker is definitely the most used one. If you're getting involved in containers for the first time, I would recommend starting with Docker, just because there's lots of tutorials and other information, and it's easy to get hold of. What does Docker do? Well, Docker is actually fairly straightforward. Docker is a client. So the Docker client, which I was just running there, is a Golang binary client. You can move that file around to different machines. It works the same way. It talks to the Docker daemon, and it talks over a Unix socket file. So a Unix socket file is just a way of making a server available without putting it on the network. But basically it's talking to a web server. The Docker daemon is just a REST API. If you're used to using REST APIs, you use web app stuff, then Docker daemon's pretty much a REST API. The Docker daemon then will go and get any images it needs from a container registry. It could be Docker Hub, could be any of the other many registries, which is also a REST API. So if you're a pen tester and you've got a background in web app testing or web API testing, you'll find that a lot of the stuff in container land is just a series of REST APIs talking to each other. They just hide it really well under like some nice fancy GUIs and CLIs. And then what we're doing is we're starting containers. So that's all Docker actually does. It basically gives a REST API command to Docker daemon, which then starts a process on the machine. So it's actually not too complicated. And we can kind of demonstrate a bit about how it works. So if I do socat. So if I do this command, socat, if you've not come across it, is a really handy tool for playing with traffic and intercepting things. This socat command basically just says, give me a new socket file, and then send any traffic you get to that socket file to the Docker socket. Right? So all I'm going to do essentially is put something as an interception so I can look at traffic and see what's going by. If I hit enter on that, it'll sit there quite happily and listen. And then in the other terminal, if I do sudo, if I then tell this terminal, hey, Docker, please go and talk to my temporary socket file that I just created and give me a list of container images. It'll do that. In this terminal, it says, okay, there's your list of images, what would I expect? But back here, we can actually see what happened. And literally, it's just a REST API. What it does, it starts off sending a head message to _ping. So it basically says, hey, Docker daemon, are you alive? Are you there? It says, yes, I am. Got a very nice distinctive user agent if you're ever looking for it. Gives back a 200. And then it says, great, go to this API endpoint. So just API version, images, JSON. Really simple REST API. And Docker comes back and says, cool. There is a list of all the things, big JSON blob. So Docker really, that's what it does. That's all it does. It's really fairly simple. It says, I'm going to tell you to do various things with containers, and you're going to launch them up for me. One thing to mention, as pen testers, you sometimes need like fine-grained control over what your tools are doing, like what exact networking you're doing. If you do any low-level testing, anything to do with like network sniffing, Docker Desktop is what you will use out of the box if you are running on Windows or Mac. Docker Desktop hides some complexity from you. It looks very nice and it works really well. But if you're doing networking, I would kind of recommend avoiding it, because what it does is it inserts this Docker Desktop thing in the middle, and it actually hides a Docker VM. And that virtual machine, you can't even see it if you're on Windows, you can't even see it in Hyper-V Manager. It will not show up. And it works really nicely if you're just doing developer work or you're doing like high-level work. If you're doing any network testing, I would recommend avoiding this, because it does quite a lot of fancy network magic, is the only way I can put it, and it's just going to get in the way of your tools. What I would typically recommend is getting a VM you manage yourself and installing Docker on top of it. Don't use Docker Desktop. Just worth knowing as pen testers. Really nice piece of software, but does a lot of magic. I don't like magic when I'm pen testing because it things break in the middle of a test. I'm like, why did you break? And the answer is some complex magic broke on me. So a very important thing to know about Docker is Docker's security model. The security model is what I always describe as flexible. What it is Docker will say that anyone who can run Docker commands on a machine can be root on the machine. That is by design. That's not elite hack. It's just the way it works. It has all these different layers of isolation that I showed you on the graph earlier on. And it says anyone who can run Docker commands can remove all of those layers of isolation at any time in any way they want. So the culmination of this is this command here, this rather long-looking command. This was from a blog in 2015 by a guy who called it the most pointless Docker command ever. When I was pen testing, this was my favorite Docker command, and I know how sad it is to have a favorite Docker command. This is my favorite Docker command, and I'll show you why. Because we can demonstrate this one super simply. Focus. So, this Docker command, very long, what it basically does is this. It first runs a flag called privileged. And I was actually talking to the guy in Docker who designed this flag, and he said they wanted to call it insecure, but their management wouldn't let them. But that's what it is. That's the remove all the security flag, which is great that it gives you one of those. It's the bane of container security existence, the fact this thing was ever made. Because it's basically the turn all security off, but it makes things work, right? So a lot of people will do it, because hey, things work really easily if I turn all the security off. We then say, okay, you know how we were getting isolated file systems and networking everything? We don't want any of that. We want the hosts networking, we want the hosts process list, we want the hosts everything. We then want to mount the root file system from our local machine into the container. And then we want to run the command chroot/host. And you can guess what happens when I run this. Before I run this command, I'm an ordinary user on this machine. When I run this command, I'm the root user. It's that simple, it's that straightforward. That is by design, that's how Docker works. If you let anyone run containers on a machine, if you're a pen tester and you find a Docker daemon, just run that command and you get to be root. If you're doing Kubernetes and you've got lots and lots of machines, which basically Kubernetes just runs lots of Docker machines on different hosts, you can run Kubernetes commands that do the exact same thing and you get to be root on every single machine in the cluster. This is by design out of the box. That's how containers are meant to work. It's very important to know when you're using them. That's just how they work. So why do we need these things as pen testers? This was kind of the point of the talk. We've seen how they work. We've seen what they do. Why as pen testers would we want to use these things? For my money, there's a couple of reasons. First one is, if you're a pen tester, you have a new environment for every customer every week. And of course, you never ever keep an environment from previous times that might leave test data from previous customers in the same place. That has never happened to any pen tester ever. Yeah. Containers make it a bit easier to keep that stuff clean, right? Because whenever you start a container, you get a new ephemeral environment, right? It goes away as soon as all the configuration goes as soon as you stop that container. You start another one, it starts clean from the same template you had before. Containers make it easy to get clean environments for your tools, so you don't run that risk that I'm going to be, hanging data to me hanging around from previous times. Another thing is, I'm guessing anyone who's ever been a pen tester has found some tool, they're on some obscure technology, some web app that they don't normally do, and they find a tool that someone wrote 7 or 8 years ago using a really old ropey version of Perl or Python or Node or whatever, and it uses a whole lot of old libraries and old versions of language. The last thing you want to be doing is installing all of those on your shared virtual machine. Because if you do that long enough, you will break your machine. And everything will go wrong, and Node or Python will start complaining horribly. Containers let you isolate those things in a nice little bundle that stays isolated and away from anything else. So you don't have to worry about the fact that it's going to make a right mess of my machine. This is probably one of my favorite places to use containers, is you can run old software all the way back to, really old versions of browsers, whatever else, in a way that won't make a mess of your virtual machines. So containers are good for that. Another thing they're good for is they're very easy to maintain. We've been seeing some talks about CI/CD and GitHub Actions and stuff like that. It's really easy to maintain containers using CI/CD. You can have, I'll show, I actually have mine, the ones I have, I basically ping them every week and they refresh and they just rebuild. So I know when I pull my container, it's no more than a week old every single time. And again, some customers are a bit picky about you rocking up with really old out-of-date software. So you can say, hey, look, my software is all really new because it gets maintained automatically. And the last time is, obviously, as pen testers, you're going to get asked to test things like Kubernetes clusters, and the customer's default place will be, give me your container image you want to run. So you kind of have to have them because customers are expecting them. So, VM versus container. Obviously, lots of people, most testers, I would say, probably use virtual machines. I'm not going to tell you that it's always right to use containers. Sometimes virtual machines are the best option. The main difference for my money is size. A VM image will end up being 10, 20, 30, 40 gig quite easily. Containers, you can get them all the way down to, I think the smallest viable container is measured in kilobytes. But realistically, even my biggest, most bloated container image that I just chuck everything into is 1 or 2 gig. So it's much easier to move around to say to a customer, here is this thing, it's much smaller. You don't have to worry about file system limits or stuff like that as much. But ultimately, there's different ways of looking at it. So, say you've decided you want to use containers, and you're thinking to yourself, where am I going to get my container images from? The first place you will think to go to is Docker Hub. Docker Hub has somewhere north of 8 million images currently available for you to download and run. Of those 8 million, about 200-ish are what I would call semi-trusted, as in they're maintained by Docker and either a commercial company or an open source project that actually says we maintain them. The other, whatever 8 million minus a couple of hundred is, are totally untrusted, could be literally anything. Doesn't matter what they say they are, there is no curation at all. They might take down malware where they get notified of it, but realistically speaking, most of the time that just means you'll get stuff that hasn't been patched in 5 years, 6 years now. There's stuff up there that just never gets patched. The person puts the image up, they use it for whatever they use it for, they forget about it. If you go searching for it, you might end up pulling it down, you get out-of-date software. But you could also get images that are called anything. There's typo squatting attacks, there is active malware on Docker Hub, there is anything you like. Typically, the best thing to do is, outside of the official images, never pull directly from Docker Hub for production tests. You're doing some research on a throwaway laptop, fine, don't worry too much about it. If you're going to a customer's production environment and you're going to start running the tools from these images against customer's production, do not do this from Docker Hub. The reason I mention this specifically is this. These are some of my images on Docker Hub. These images, the top one there is literally just Alpine Linux with a couple of networking tools that I literally did for throwaway years ago. The next two are my kind of like kitchen sink where I put all my container tools. And those are the download stats. I can promise you that I'm not even 0.1% of those download stats. So some people, somewhere in the world, have decided to make heavy use of these images that I put up there. I make no providence about maintaining them, not putting malware in them, not rickrolling anyone who runs them. I say nothing about them. No one has any assurance. But that does not stop people doing it. That top one's 1.75 million downloads. I don't know who's doing it. I have no way of knowing who's doing it. I mean, I could actually put a tracker into them. You can do that. You can put trackers into container images. I haven't. I could. To find out what's going on. But that's why I'm saying why it's a problem, because people totally do this. They just download images of Docker Hub and run them. And if you're a pen tester and you're doing this against production environments, please don't do that. Make your own images. Making container images is fairly straightforward. It's not super complex and super obtuse. One thing you can do with container images, most of the time they'll actually generally be linked to a GitHub repository or something else. And in there, there'll be a thing called a Docker file. I'll show you in a second, but Docker file syntax is really quite straightforward. It's really fairly basic. My typical rule of thumb is if I want to get someone's Docker image, I just go and copy the Docker file. You just make a copy of it, look at it, build it myself, because then I know what's in it and I know how I can patch it and maintain it as needed. It's not hard, but do build your own images. Don't just use random images off Docker Hub, because sooner or later someone will have bad OPSEC. I mean, I might have bad OPSEC for all that anyone knows. I might have left my Docker Hub API key lying somewhere. Someone steals it, corrupts those images, and suddenly people are downloading them. Not good times. So do make your own images. In terms of what you do, how you make those images, there's two major approaches. Tool specific versus kitchen sink. Tool specific, I'm going to make one container image for every tool I run. This is the purist's way. If you talk to container purists, they'll say containers should only run one process. I'm a pen tester, I'm not really a purist. Realistically speaking, I have tried that approach. It's a pain to maintain. You have to have one image per tool. Every time you go do an assessment, you have to remember to put all the right images. Kitchen sink image, you just put all your tools in one image and run a bash shell. So when I start the container, it just runs a bash shell or a ash shell or whatever other shell you like. Works perfectly well. That's typically how, when I was a pen tester, I would do it. I would say, for example, I've had all my tools for container work. Put them into one image. Okay, away you go. So when you're choosing an image, you want to build your own images. I'm convinced you containers are a great idea. What do? You have to pick a base distribution. Now, there's lots of different options for this. As I said, there's hundreds of images you could use as base. Typically, they all come down to choosing a Linux distribution. My advice here is pick the one that you're most familiar with. People used to advise you always to use Alpine at the top there because it was quite small and slim. These days, it's not so much of a problem. If you're a Red Hat person, pick the Red Hat. If you're a Ubuntu person, pick Ubuntu Debian. The only one I put at the bottom is don't use CentOS, or at least don't use it from Docker Hub. The reason for that is the CentOS image on Docker Hub is unmaintained. It is an official image, but it is unmaintained. And unless you go to the website, you won't know it's unmaintained, because it doesn't say on the command line anywhere. You can totally build your image off CentOS 7, and you'll get something that hasn't been patched, I think, since November last year. Might even be November the year before that. It's been a while anyway. And if you talk about images that shouldn't get used that does, that one's had millions of downloads. Lots and lots of millions. But anyway, don't use CentOS. Apart from that, pick a distribution that you want. There's one other option you can have, which is up the top there. It's called Scratch. And Scratch essentially is give me a completely empty container image. So if you're looking for super minimal, super small, you can start your image from scratch, but it has no operating system libraries in there at all. So like no time zone files, no TLS certificate files that your program might need, nothing. So only do that if you're doing like statically compiled binaries. So if your tools are all statically compiled binaries and you're super good at making them work without supporting files, Scratch is kind of cool because it makes really small images. Docker files. Like I said, Docker files are not super complicated. Docker file syntax is not highly obtuse. Basically, it works like this. You start off with a from, which is your base image. In this case, Ubuntu 2204, which is my favorite base image. You then basically say to the Docker file, do whatever you would need to do to install the tool. Right, in this case, I'm installing nmap. So I just say run apt update. Okay, I need to update apt to get the latest packages available. Apt install -y nmap, and then apt get clean. The reason I do that all in one line, and if you read Docker files, you'll see tons of this and, is to do with how it builds up layers, and basically it leaves files from earlier lines before if you don't delete them. So you want to get everything on one line. You want to clean up after yourself. Get rid of the cache, put it all on one line. And then you just say, whenever this container is run the command nmap. It's super simple. So that is an incredibly simple, that is an nmap image. That will happily run nmap in a container. So I can demonstrate that. How are we doing for time? We have 7 minutes left. I'll maybe just do the second part of this then rather than the first. Let me get this. Because I do want to mention one specific thing. Go back out here. This one. Yeah. Okay, so this basically runs that command. Now, the reason I had this command up is I wanted to mention it, is what I did here was I said ---- net host. So by default, when Docker runs, it gets an IP address on an isolated network, right? And then it uses IP tables under the covers. It doesn't tell you it's IP tables, but it's just IP tables, to essentially get the traffic out to the rest of the world. If you're doing pen testing stuff, like low-level tools, Wireshark, Nmap, anything that does networking, I generally advise putting net host on there, because then you're just running using the host's network adapter. You don't have to worry about any NAT stuff getting in the way, making, NAT tables filling up, things breaking, which it might do otherwise. And you can run this quite happily, and it will... It just runs nmap. And you can see, because of the way it's run, anything I gave after where it says nmap is just treated as nmap flags. So you just give it the nmap flags, just like you were running nmap on the host. And it works quite happily, and you get your nmap flags. And then run nmap. And you can do that for any tool you like. So remember, these things are just processes. All you're doing is running nmap, just as though you're running it on the machine. Except you've got it isolated away, and you could have an old version nmap or a specific build of something you need to have. You put it in a container image, and away you go. Root versus non-root. The other canonical sin of containers is that all containers run as root by default. This is because container people like things to work. They don't like things not to work. So they made the decision to make every single container run as root by default. If you don't tell it otherwise, you're running as root. As a pen tester, this is fantastic, because what we do like doing is running as root, because then things don't get in the way so much. It's not as bad as running root on the host, because you are still somewhat isolated. But if I was giving this talk to developers, the first thing I always say is please stop running all your containers as root, because it makes it easier to break out. If there's a Linux kernel vuln, running as root makes it much easier to exploit that. As pen testers, we typically just want to run as root. I would recommend, as long as your customers are letting you do it, run your containers as root. It's the default anyway, they'll probably be used to it. But there is a trick. If you are told not to run as root, so a good example of this, if anyone's come across a tool called Red Hat OpenShift, Red Hat, this is their Kubernetes, this is their way of running containers in enterprise. If you do containers in enterprise, you will probably encounter OpenShift. It has a default position of you will not do this. They've taken the sensible default of you will not run all your containers as root. This is bad. But as pen testers, we might say, well, okay, we can't. So then you give your customer, you say, I'm running a container in your cluster, and they say you can't run that because it's running as root, it won't work. And you go, okay, I need a container that doesn't run as root. There's a way to get root back, though, which I wanted to mention because it's super simple. All you do is you basically, in your Docker file, you say, give me a setuid root shell. And please, I've got it setting as setuid root there, 4755. Oh, fancy flash. And then all you do is you can then, when you're running your container, you just run that setuid shell, and you're back to being root again. Now, they can block that, but it's not a default setting. So if they've super hardened down their cluster, that won't work. But if they haven't super hardened down their cluster, that will work, and you get to be root again. So if you're doing all your container stuff, you can do it that way. There's some other tricks as well, but that's I use that one quite a lot, because otherwise, I can run as root. One other problem, this is the one thing that will trip you up if you use containers. When you run your container, the file system is isolated, right? So when I dump it, I put the output of my mmap command somewhere, it's inside the container, not outside the container. So the obvious problem is, how do I get my data back, my test data, back out to my host machine? And that's really simple. You just use that switch down there, -v. See, it says -v test data. Why did I do that? I will not try that again. -v test data, and then maps it into the container as test data. So anything I put in the test data directory inside the container will turn up on my host in home directory /test data. And you can make those names anything you like. But that's just the trick you need to know, that when you're running these containers, it's the one additional thing you have to think about is, how do I get the data back out of the container when it's finished, if I'm outputting to a file. If you're outputting to screen, don't worry about it. It'll show up quite happily. But if you're outputting to a file, you do need to know about that, which is the volume switch. And that one should work quite well. So, in conclusion, containers are not too bad once you get used to them. You have to get your head around the idea of this thing running this kind of isolated process. But they do help a lot. They help keep your tool environments clean. They help with when you've got old, ropey tools that were written in Perl 10 years ago and haven't been maintained, but are the one thing that on your pen test you really need to make work. And they also help if you are doing jobs in Kubernetes and Docker environments, which is ever more common. When you see these kind of jobs, customers will start saying things like, well, I'm expecting you to be able to provide me a container, Mr. Run. And they're very helpful if you're doing Kubernetes work as well. There was quite a lot of stuff there, so I put some resources. Top one there that's my kitchen sink image. Please copy that, fork the repo. Have a look at it, make sure you're happy with what's on it, build it yourself, maintain it yourself, or just take bits of it you like. Next one down, I did some of the tool-specific. I experimented with tool-specific images. Fundamentally, I've not maintained them, so again, don't just run them. Please do check you want to maintain them before you use them. This year, we're doing a series on container security fundamentals. So if you've looked at this and thought, yeah, that's nice, but how exactly does that work? We're doing a lot more. We've covered namespaces, capabilities, and C groups so far. So we'll get around all of them, though. This is a site I maintain, a container security site. This has got things like manifests. If you want like a Kubernetes manifest that will give you root on every single host in the cluster, I've got one there. So you can run that and see how it works. And if it works, then go and have words with the security team, because that shouldn't work. They should have blocked it. And then lastly, this one here, I got annoyed because I couldn't find like all the materials about container security. There's an archive of 600, there are 620 talks about cloud native and container security from KubeCons and cloud native security cons going back to 2016. There's a search function, so you can search any of them and just say, I want to know more about Kubernetes RBAC, or I want to know more about isolated containers, and you'll find hopefully some stuff in there. You can add all of these are GitHub repos as well. So if you want to add anything, well, not the Datadog one, but all the other ones are GitHub repos. So if you find something you want to change or add, pull requests are always welcome. And we're dead on time. And those are my contact details. If you want to ask any questions, probably not time now, but there's my email address, there's Mastodon. If anyone's still on Twitter, there's Twitter. And hopefully that's been interesting.